Okay, good morning, everyone. Okay, today we'll be looking at lesson 3, using trig ratios to find side lengths. So this is on page 6 of your booklet, and our main goal today is to determine the side length of an unknown side of a right triangle using sine, cosine, and tangent ratios. Now, these are new terms for most of you. Some of you may have heard it before, because it's very different from lesson 2. In lesson 2, we use the Pythagorean theorem. Now, the Pythagorean theorem can only be used when you know two sides. So if you want to find three sides, the third side, that's the Pythagorean theorem. Now, what happens when we only know one side, or the length of one side? Then we can't use the Pythagorean theorem. But there are three other formulas we can use to find the missing side. So to recap, with the Pythagorean theorem, we need to know two sides to find the measure of the third side length. If we don't know two sides, then we cannot use the Pythagorean theorem. We have to use what we call the trig ratios, and there are three of them: sine, cosine, and tangent. So the sine, as we will look in further details later, is the length of the opposite side divided by the length of the hypotenuse. And the cosine is the length of the adjacent side divided by the hypotenuse, and the tangent is the length of the opposite side divided by the adjacent. But before we go into labeling the sides of a triangle and finding the missing side length, when we know that an angle and a side, we have to understand the concept of opposite, because that is very important for us to label our triangle and to find the missing side length. So the concept of opposite and adjacent. So those are the two terms we'll be looking at: concept of opposite side and adjacent side. So the labeling is critical because we have to know, first of all, a reference would be the angle. This letter, Greek letter, is theta, and it's the symbol we use to indicate angle. So theta, so a little circle with a line across, like a smiley face, right? But so this is theta, and it's referred to the missing angle. Now, how do we label our sides? So first of all, we look at our reference angle, theta. So this is my theta here. So using theta, the side opposite theta is called the opposite side. Now, the side adjacent to theta, side here, is called the adjacent side. Let's look at another example. This is our theta. The side opposite it, it's called the opposite side. And the side adjacent is called the adjacent side. Notice the hypotenuse is the longest side, but sometimes it's very difficult to tell if it's the longest side. But the way you find out if it's the longest side is by looking at the right angle. We learned from lesson 1 that this kind of a square where these two lines meet perpendicularly, that's referred to the hypotenuse. So to recap, to label the sides of your right angle triangle, you first find a reference angle, and then the side opposite that reference angle is called the opposite side. The side adjacent to it, which is beside it, adjacent means beside, is called adjacent. And the hypotenuse is always the side opposite the 90-degree angle. See this one over here, that's hypotenuse, just the angle. Now, let's go on to the next page, and we look at some example on how we are going to label sides of a triangle. Now, that's the wrong page. So on page 7, so page 7. Now, using what we learned from the previous page and how to label, so we are going to use this as a reference. So I'm going to slide this over here, and this uses my reference angle. Notice, and I'm going to label these accordingly. So notice this is my angle again here. So the side opposite this angle is called the opposite side. And the longest side, or the side opposite the right angle, is called the hypotenuse. By the way, sometimes we label using a shorthand to label the sides, hypotenuse, adjacent, and opposite. And I'll do that here. This is my angle, so this is my opposite side. This is my hypotenuse, and this will be my adjacent side. This is my reference angle, so this is my opposite side. This is my adjacent and hypotenuse. Angle, opposite side, adjacent side, hypotenuse. This is my reference angle, opposite side, hypotenuse, and adjacent. Now we have 4 more we could label here. And you can see the pattern, right? I'm always looking at my opposite side first. And adjacent, second. And this would be my hypotenuse. Angle, opposite, adjacent, hypotenuse. Angle, opposite, hypotenuse, adjacent, angle, opposite, adjacent, hypotenuse. So there we go. How we label the sides of a right angle triangle. Now we're familiar with the vocabulary, we turn to our formulas. The sine is the sine of an angle. That means the sine of an angle is equal to the length of the opposite side over the length of the hypotenuse. So if you would like to write here length, and you have a length here. So we're looking at the length of the sides, right? The cosine is the angle, the cosine of an angle, I should say. So here we have the cosine of an angle is the length of the adjacent side over the hypotenuse, and the tangent of an angle is the opposite length of the opposite side over the length of the adjacent side. Now, many people use this acronym SOHCAHTOA to remember the correct combination and order the sides for each formula. Also, some people prefer to write it in this way. SOHCAHTOA, the sine of an angle is opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. So these three trig ratios we'll be using to find the missing side length when we know one angle on one side. So let's look at two examples on the next page, page 8. So here we have a triangle, a right angle triangle, and we're given the angle of one side and the side length of the hypotenuse. Now, I want to remind you, whenever you calculate any of these, you have to make sure your calculator is in degree mode. I'll show you using my graphing calculator. Now it's very difficult trying to find it where I don't see a reflection. There we go. So I put my calculator on. Now with my calculator on the mode be in degree mode. So I get out of here. Then if I'm calculating the side length. So the first thing I would like to do is to write down my trig ratios in front of me. I'm going to write SOHCAHTOA. So to remind me what I have to use and the order in which I'll be using them. Secondly, I would like to label, and each question you do, follow this procedure. Look at my reference angle and label. So step 1, so label the sides of a triangle. So let's label the sides of this triangle. So using a reference angle. So this will be my opposite side. Now the side adjacent to the angle, reference angle, is the adjacent side. And the longest side, or the side opposite at 90 degrees, is the hypotenuse. Now by labeling it, it will help me to determine which one of the trig ratios I should use. So the next step, I write down what's given and what I need to find. So given, I given theta, 72 degrees. I'm given the hypotenuse, which is 29 millimeters. And I'm asked to find the adjacent side, which is x. Now, I have 3 trig ratios. I have to figure out which one to use. So what I do, I'm going to go to my trig ratios here, and I do have them all written down. So I'll have them written down, and I'm going to go back to it and say, okay, what do I have? I know my theta and hypotenuse. So where does it apply? It applies to hypotenuse applied to these two here, sine and cosine. So I know tangent is out. Then I'm asked to find adjacent. Now, adjacent is not here, so therefore I'll be using cosine. So the cosine theta is my trig ratio. So I'll write that down. Cosine theta is adjacent side over the hypotenuse. So this is my trig ratios. So cosine theta, I'll write this down. So cosine 72 is equal to adjacent, which I don't know, with x, and a hypotenuse, which is 29. So x now is equal to 29 cos 72. Now I'll go to my trusted calculator and I'll show you how to do that. So I'll punch in 29, then I'll press my cos button, 72, close bracket, and it gives me 8.96. So x is 8.96. In this case, is millimeters. Let's look at the next question, example, I should say. Example 2. So step 1, we label both sides. This is my reference angle. So this will be the opposite side because it's the side opposite my reference angle. X is the hypotenuse because it is opposite at 90 degrees. So I'll write HYP here. So that's my hypotenuse. So and fine. And this third step, we select our trig ratios. So given theta, which is 55 degrees, I'm given the opposite side, which is 27 feet. And I'm asked to find the hypotenuse. And here again, I'll go to my reference trig ratios. And I'll just rewrite them here. So we have sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent. Now, which one of these three should I use? Now, to know which one, I simply look what's given and what I need to find and see where they match side. Here we have opposite side. There's no opposite side, so I know this is out. X across. Here we have opposite side, so tangent is a possibility and sine is also a possibility. But look what I need to find. I need to find the hypotenuse. Hypotenuse is here and not here, so I know this one is out. So I'm going to use sine theta. So I'll erase these two here because I don't need them anymore. They are not useful for this question. So now sine theta, I'll write it here, sine 55 is equal to the opposite, which is 27 over x. So x is equal to 27 over sine 55. And this is where I'm going to go to my calculator. Good old trusted calculator here. And I have 27. Remove the previous one. 27 divided by sine 55. Press enter, and it gives me 32.96 feet. So x is 32.96 feet. So recap, whenever we are solving for a missing side length of a right angle triangle, when we're given one angle on one side, we label the sides first using a reference angle. Then we write down what's given and what needs to be found. Then we use what's given and what's need to be found to our reference trig ratios and find that there's a match. Where there's a match, that's the one we'll be using. And then we solve using a wonderful trusted calculator. So for your assignment today, you will go to page, we're looking at page 9. In your booklet. So this is your assignment for today. So page 9, assignment 3, and there are 10 questions to be completed. You can check your answers at the back. Tomorrow, I'll post detailed answers to these, and you can check the blog for any assignments due. Now, I did mention to some of you need to submit your assignments the next day or two. That is fine. I'm still receiving them by email. See you tomorrow.